Hey guys, it's me, Miss Mills, and welcome to Mrs. Mills' Math Time. The whole point of this video is to help you out with comparing functions notes. Here's how this is going to work out. You're going to write the notes below, so you're going to write the notes on all of the slides, and then you're going to watch the video at the end. And on slide 3, which is right here, we're going to find the rate of change of this equation, these ordered pairs, the table, and the graph. And then at the very end, we are going to compare them from least to greatest. So just follow along and we are going to compare functions together. So when we're comparing functions, we are going to compare the rate of change. And it says we can compare functions by looking at their properties such as slope or rate of change. So basically what I'm trying to say is slope and rate of change are two words that mean the exact same thing. So to find the rate of change, we can use the slope formula or we compare the ratio of rise over run. So if you remember from last week, I did talk about the slope formula and rise over run. Those are two ways that you can find the slope of a graph. You can use the slope formula to find the slope of a table in ordered pairs as well. So again, when we're comparing the rate of change, we're comparing the slope. So to compare functions, we need to find the slope of each function, and then we can compare them from least to greatest to least, or whatever is the requirement. So let's go ahead and do this then. So let's do some examples below. First, we need to find the slope or the rate of change of number 1, which is this equation. So I'm going to write something down real quick. Y equals 6x plus 9. Okay. So if y'all remember slope-intercept form, it's this right here, y equals mx plus b. And when you have y equals mx plus b, m is always your slope and b is always your y-intercept. So when you have an equation just like that, whatever number is where m is going to be your slope, and wherever the number b, or whatever number is where b is going to be your y-intercept. So in this problem, our slope is going to be 2/5 because that is where the slope is in the equation. It's always right next to this little pesky x. So the slope of this equation is 2/5. So now we can go back to our function notes and we can type in 2/5. That's our slope or the rate of change of that equation. All right, so next we need to find the rate of change of an ordered pair. So here's our ordered pair, so I'm going to go ahead and write that down real quick. We have 5 and 7.5, and then we have 6 and 9. All right, cool. So here are our ordered pairs. And if you remember, when you have an ordered pair, your first number is always going to be an x, and your second number is always going to be a y. So using that information, 5 is an x, 7.5 is a y, 6 is an x, and then 9 is a y. And now our last step is, since this is the first ordered pair I see, I'm literally going to make this x1 and y1. And since this is the second ordered pair I see, I'll make this x2 and y2, and now I can put it into the slope formula. So if you remember, the slope formula is y2 minus y1 over x2 minus x1. And I need x1 I need y2 first, so y2 is 9, so I'll go ahead and put that down. I can mark it out. Then I need y1, which is 7.5, and again, we are subtracting this because that's what the formula calls for. Then I need x2, which is 6, and then I need x1, which is 5, and now I can subtract. So 9 minus 7.5 will give us 1.5, and then 6 minus 5 will give us 1. So we have a rate of change of 1.5. So using that information, we can go back to our slope, and where it says number 2, we can write down 1.5 as our rate of change for that ordered pairs. So I'm noticing that some things are fractions, some things are decimals. So what I recommend doing when you're comparing is, make it to where it's easier to compare. Like for example, 2/5 is also known as 4/10. So now I have two decimals, and it's easier to compare 1.5 to 0.4. So I already have that written down. Next, I need to compare the table rate of change. Here's our table. And again, I'm going to pick an x and a y that go together, and then another set of ordered pairs. So my first ordered pair is 5 and -5. And my second ordered pair is 7 and -11. And I have it written down, so now I can put it in the slope formula. So again, we have x1 and y1, because our first number is always an x, our second number is always a y, and this is the first ordered pair I see. And then this one's the second ordered pair I see, so I'll go ahead and write that down too. Slope formula is y2 minus y1 over x2 minus x1. So I need y2 first. So y2 is negative 11, so I can mark that out. We're going to subtract that by negative 5. And then we have 7. We're going to subtract that by 5. And now I can go ahead and do this problem. So negative 11 minus negative 5, when you're subtracting from a minus sign, you can turn that into a positive. So now this is turned into negative 11 plus 5, which is going to give us negative 6 left over. And then 7 minus 5 is going to give us 2. This can be reduced. Negative 6 divided by 2 will give us a negative 3, making our slope or our rate of change negative 3. So we can go back here, and same thing, we'll put negative 3 here. And now we just have to find the slope of the graph. So I'm back looking at the graph, and I'm going to make it bigger so you can see it better. And let's pick 2 points where it crosses an intersection or grid point. So let's make, or I guess I can draw. Let's make my first point right here. That works. And then if I follow the line, the next time I cross a grid point is right here. So here are my 2 points. And again, slope here is rise over run. So it's always going to be a fraction. And how much I rise from my left point to my right point is going to be my numerator. And how much I run is going to be my denominator. So from my left point to my right point, I rise 1 time. So my numerator is 1. And then I'm going to run 1, 2, 3, 4 times. And my denominator is 4. So the slope or the rate of change of this problem is going to be 1 over 4. So let me erase all that work that I just did. And now we can go back. Oh, no, that's not what I want to do. I'm going to make it to where I can see again. Awesome. And the graph rate of change is 1/4, which can be changed to 0.25 or 25 hundredths. And now I have all the numbers that I need, and I can compare them from least to greatest. I'm not going to do that for y'all, so the rest of it is on your own. Figure out which one of these numbers is the smallest, and then you can put these numbers in order. So for example, the smallest number is obviously negative 3. I mean, it's the only negative on there. So negative 3 is the third number, so I can take number 3 and I can bring it to the front. Oops. Knowing that that is the smallest number. And guys, I'm going to let y'all finish this up. So if you have any questions, don't hesitate to ask, and I'll see y'all later. Bye.